So skill 2-1 is over equivalent and simplifying or reducing equivalent / simplifying fractions. Okay? Equivalent / simplifying fractions. So yesterday we went over equivalent. Okay? That's kind of what this process was. What number would this question mark have to be in order to make these two fractions equal? Okay? So simplifying, get something in its simplest terms, is another form of finding an equivalent fraction. Okay? It's another form of finding an equivalent fraction. So, what does it mean to simplify? Raise your hand. What does it mean to simplify? Moody.
Reduce.
To reduce. What does it mean to reduce?
Make smaller.
To make it smaller, to put it in its smallest terms. Alright? Well, how we're going to do that today is we're going to go back to Unit 1 and use one of our skills to do that. Okay? Who do you think we're going to use to make it smaller? Dividing. Okay, so divisibility rules maybe take place. What else kind of made things smaller? Well, did we do any subtraction last unit? No? Think about what we did last unit. What did we do last unit? What is smaller than the original number? What type of number is smaller than its original? It starts with an F. Factor. Factor. We're going to use greatest common factors to help reduce or to simplify fractions. Okay? Here's the key to success. Alright? When you divide both numerator and denominator by their GCF, you win. What do I mean by you win, Shelby? If we divide both the numerator and the denominator by their GCF, what do I mean by you win? What are we trying to do? So we've got it, that fraction in its simplest form. If we divide by the GCF every time, we're going to get it in its simplest form, no matter what. No matter what. Alright? That makes sense? Not quite yet, but it will. Okay?
Thought this was still 2. Okay.
Say what?
Thought this was still 2.
No, this is 2-1. 2-1 was both equivalent and reducing. Okay? We're still on skill, so we're adding on to what we did yesterday. Okay? So, for example, say we had 36/48. Okay? 36/48. We need to find what? Kobe? Of who?
Of the denominator and the
The numerator and the denominator. We need to to find the greatest common factor of both. Do you guys remember how to do that? How many ways can we do that? 2. One way is just to list out all the factors. The other way is to use a factor tree, right? Okay, so let's use the factor tree method. So we have 36, we have 48. What can we do for 36? 6 times 6. And then what can we break it down into? 2 times 3. And 2 times 3. Now, do I want the prime factorization, or do I just want all the numbers written out? I just want all the numbers written out. So, 2 times 2 times 3 times 3. Okay? Now I gotta do 48. Tyson, what do you think for 48? What can I break 48 down into? You gotta think about something there. What do you think? Caleb. What can you go to 48? 24. 24 and 2. Okay. Well, 2 is a prime. Is 24 prime, or can we break 24 down? Composite, we break it down. What goes with 24? Tyson?
4 and 6.
4 and 6. Are those prime or composite? Composite. Composite means we can break it down. Prime means we can't break it down anymore, right? Ben, what can I break 4 down into? Good. Are those prime?
Yes.
Yep, circle. What about 6? Gunderson. And then how do I write them out? 2 times 2 times 2 times 2 times 3. Now, is this method you take 2 friends, you find your buddy, you take the larger, or is this you find your buddy, 1 friendship? Find your buddy, you take 1 of them. Okay, not the larger, you just take the 1. So does this 2, Shelby, have a friend? Good. How many times do I write it? Good. Does this 2, Kobe, have a friend? Yes. Write it once. Does this 3 have a friend? Yes. Write it once. Does this 3 have a friend? What about these 2 guys right here? Do they have friends? No. So what is 2 times 2 times 3? 2 times 2 is what? 4. 4 times 3 is 12. So we're done, right? We have simplified the fraction. Hello?
Yeah.
What? Have we simplified the fraction?
Yeah, no.
No, we haven't even touched the fraction. What did we just find?
The greatest common factor.
So, Sam, what should I do with that greatest common factor? What does it say? Divide it from both of those, right? So I do 36 divided by 12.
Yes.
And I do 48, thank you, divided by 12. Now here you can use a calculator. Go ahead. What do you get? I have an answer. What? Already? When'd you do that?
I thought you said that, but then I had some stuff someone needs to come.
Well, I want you to try this method, okay? So, what's 36 divided by 12? 3. What's 48 divided by 12? 4. There's our reduced fraction. So what's true about 36 48ths and 3/4? Those are equivalent. Those are the same fractions. Okay? Because we divided both top and bottom, just like yesterday when we multiplied both top and bottom. They're the same thing. Okay? So I want you guys to try it on your own using this method. I want you to use this method, try it on your own. Okay? Let's do 15 25ths. Simplify. Use the greatest common factor method. Go. For 64 and no. Did I do 64? Yeah, 64 and 72. Would you do that? Okay, so we're simplifying 64 over 72. Here's 64. Here's 72. What can I break 64 down into? Tyson? 4 and 16 is good. Are either one of those prime? Are those prime, Sam? No, so I got to break them down even more. Sheldon, what can I break 4 down into?
2 and 2.
Dos y dos. 2 and 2. Good. What about 16? Tyson?
2 and 8.
2 and 8. Can I break 8 down?
Yes.
What can I break 8 down into, Sam?
Why'd you circle it?
4 and 2.
I don't know why I circled it. I guess I'm not all here. There. Whatever you want to say. 4 and 2. Can I break down 4?
Yes.
There's 2 and 2. Holy 2.
OMG.
How many 2s do we have?
5, 6.
6. So I write 2 times 2 times 2 times 2 times 2 times 2. Right? Do I want to write it as 2 to the 6th power? No, not for greatest common factor. Now we gotta do 72. Woo! What can I break down 72 and 2? Patrice, what can I break 72 down to? 24 and 3 would be what? So I'll put the 3 here, I'll put the 24 there. Good. What can I break 24 down into, Gunderson?
2
And?
1.
Good. What can I break break 12 down?
6 and 2.
6 and 2, good. And then what can I break 6 down into? 3 and 2. Only I can make noises. License to talk, you're taken away. Shh. That's 5 seconds. So, what do I do from here? Shh. What do I do from here? Somebody new. Shh. What do I do from here? Show me.
You do 2 times 2 times 2 times 3 times.
Good. So I've written them out. Now, I need to find what? What do I need to find here, Caleb? I need to find buddies. Does this 2 have a buddy?
Yes.
Yes. How many times do I write it? Does this 2 have a buddy? Everybody.
No.
Does this 2 have a buddy?
Yes.
Oops, I'm gonna write it. Does this 2 have a buddy?
No.
Does that 2 have a buddy? Does that 2 have a buddy?
No.
So I go over here. Do these 3s have buddies?
No.
No. They have to have buddies over here. No buddy, no 3s there. So, what's 2 times 2 times 2?
So it's 8.
What's 2 times 2, Tyson?
8, sorry.
What's 2 times 2?
4.
And then, so those are done. What's 4 times 2? 8. There we go. Okay? Don't just think you're adding there when you said 6, right?
Sorry.
It's fine. No, don't say sorry. You're fine. Okay? I just want you to see what's going on, okay? Good. So great. I'm done. Game over. Woohoo. Why am I not done, Patrice?
You have to take 8 into 72 and 64.
Okay, I gotta divide 8 from. You gotta divide 8 from. Say it with me. Divide 8 from 64 and 72. So I'll do that. Man, I'm all over the place today. 64 divided by 8. 72 divided by 8.
9.
My answer is 9? Okay. 9.
No.
Be specific then, son. What's 64 divided by 8?
8.
8. What's 72 divided by 8? 9. 8 ninths is our answer. Your homework is the back side of that worksheet you did yesterday.
We have to do final review.
No, you're doing numbers 19 through 34.